Good evening and welcome to TL Physics. My name's Sarah and today I'm going to talk about uses of radiation. There are very varied uses of radiation. However, there's some key ones that I want to make you aware of. Now, one of them is, of course, to find thickness of paper, and that is using beta radiation. Okay. Now, beta radiation is really useful because beta radiation is not stopped by paper. So beta, it is not stopped by paper, which means that if you put a beta source underneath a piece of paper and the paper goes out, as the thickness of the paper increases, the amount of beta will slightly decrease. And what you can do is monitor the amount of radiation that goes through the paper, and from that be able to work out how thick the paper is. Okay, so as the paper gets thicker, as the paper gets thicker, the amount of beta decreases. And of course you can work out if your paper is too thick or too thin by the amount of beta radiation is, and that's how they use it on mass production lines. Another use for radiation is a gamma camera. Now, a gamma camera is something used in medical science. And I'm going to place a picture of what a scan from a gamma camera looks like now. What it is that a person is injected with a radioactive isotope that is giving off gamma radiation. Okay, so this gamma radiation is being given off, you're injected with this. Okay, and a gamma camera picks up that radiation. Now, when you were injected with it, the blood went all around the body. Now, if there is somewhere where the blood isn't going, or somewhere where blood is pooling, you'll be able to work it out by the amount of gamma radiation there is. So you can use a gamma camera. So this is using, of course, gamma radiation as a medical camera to detect sources of clotting or sources of where blood isn't going or blood is going. Okay, so you can use a gamma camera to be able to detect anomalies with the body. Now, the gamma camera, very importantly, the radioactive isotope it uses is something known as technetium-99. So gamma cameras use technetium-99, sometimes written like this. This is a radioactive isotope of technetium, and the reason this one is used is for a couple of reasons. That firstly, it has a short half-life. The half-life of technetium-99 is approximately 6 hours. This means if I gave you a 1 gram dose of technetium-99, after 6 hours it will be half a gram, after that it would be quarter of a gram, etc. In reality, the dosage is much smaller than that, but a 6 hour half-life not only allows the doctors to be able to detect or have a window to be able to use the gamma camera to detect effectively, but also it means that after your scan is done, that you can, after a day, you'll be down. So a day would be 4 half-life, so 1 gram, so 1 half-life, half a gram, quarter of a gram, an eighth of a gram, a 16th of a gram. It's a very small percentage that's in your blood system after 24 hours. So technetium-99 has a very short half-life as well. Also, its products from its radiation, so the products of decay are not lethal. So for example, if if you had something radioactive decaying in you and that decayed into lead, the lead or mercury, etc., is lethal to humans. Technetium's decay, the items it decays into, are not ones that are lethal to humans. So it's a radioactive isotope we can abuse, and well, not abuse in medical sense, because it's not only short half-life, but because it's also safe to humans. Okay. Now you may sometimes see this thing with technetium, and it might have M next to it. That means we've excited that technetium. Okay, we have excited it to make it decay. So this M is excited element. And this is what we've done, it's almost like shaking it up, giving it some extra energy so it will decay. Okay, so you might see 99M, and this means it's in an excited state of technetium. Now the last one is use of smoke alarms, and that is by using alpha. Okay, now how a smoke alarm works is that you have an alpha emitter down here, and you have your detector up here. Oops. Now this detector will keep detecting alpha, but because alpha can be stopped by paper, it doesn't really take much to stop alpha. If a lot of smoke gets in here, so a lot of smoke gets in here, so smoke, the detector wouldn't detect anything, and it will start the alarm circuit. Okay, this is why, for example, if you open your oven and you get lots of steam and smoke come out, it can set the smoke alarm off. And it's due to the fact that americium, okay, americium is, so this is normally americium, which is an alpha decay. This alpha source here, basically it gets stopped by the smoke, so the detector doesn't detect anything. Now, alpha is the most ionizing to humans, so it's quite dangerous, but it's only dangerous if we ingest it. Okay, so alpha is the most ionizing, but least penetrative. This means you would literally have to get your smoke detector and swallow the americium, but the americium is in such small amounts, so we use very small amounts of the alpha source, which is americium, or AM. Even if we did ingest it, it's probably not going to cause too much damage, but I don't recommend it at all. But a small amount of americium in here, and the only way that's going to really harm you is if it's ingested. So smoke alarms are radioactive. Okay, and these are three major uses of radiation, so beta, gamma and alpha here. You may be assessed on how they could be used, or if the idea is suitable. You also may be assessed to make comments about their safety. Alpha is only dangerous if we ingest it. Gamma cameras, we use an isotope which is safe to humans but has a short half-life. Beta is in the middle, it's not really ionizing, it's not really penetrating either. So the beta paper thickness one, of course, is very much, you have to put labels out, etc. But beta being beta, it's not as dangerous as either a gamma or a smoke alarm here.